All right, so here is the evaluate cooldown day 2. So we're going to do this on either the handout or the notebook paper that you have. Please remember to use Cam Scanner or your Apple Notes to upload this in. That way it's easy for me to see. So lesson 7, interpreting and using exponential functions. Here's our cooldown. Half gone, again and again. A scientist models the number of grams of radioactive substance with an expression 15 times 1/2 to the power of d divided by 5. D is the number of days since the sample was measured. After how many days has half the substance disappeared through a radioactive decay, which is the whole thing that we're looking at, right? So if D represents the number of days since the sample was measured, and if we notice down here, we can see that 5. So we know that 5 days would be the half-life. And I'm not going to type it out, but for you to explain your reasoning whenever you write it down, don't just put 5 days. Put because we know that an entire half-life or half of the substance being decayed is going to happen after 5 days. One full cycle showing in the division of the exponent shows us a full cycle is 5 days. Okay, so that's how you get it. Question number 2 says, after 20 days, will there be more or less than 1 gram of substance left? Explain your reasons. So 20 days, we can just plug that in for D. So 15 times 1/2 to the power of 20 over 5. We know that that's really going to be 4, right? 20 over 5 is 4. That's going to be equal to 4 cycles. So 15 times 1/2 to the power of 4. And then we can just plug that into Desmos or whatever calculator you're using. So whatever 1/2 to the power of 4 is, and then multiply that by 15. Looks like I get 0.9, let's round it to the nearest hundred, 4, and that is going to be less than 1 gram of the substance since it models grams of substance. So that's less than 1, therefore that is our answer. So there is how you do lesson 7 cool.